is only one perfect solution. There are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb, and today we're going to be taking a look at another KTANE modded module tutorial. And today what we're going to be focusing on is warning signs. So this is the way that the module looks. It is an equilateral triangle, and in the middle of it there will be some sort of hazard that will be described based off of a series of icons that can range from skulls, to flames, to even a person falling off of a building, it appears to be. So what our objective is we need to first figure out what we're going to be looking at here. So what exactly is our goal? So our goal here is we need to simply unscrew these three digits, these three screws rather, excuse me, based off of the last digit of the timer that we get from three results in this case. So the first things first is we need to figure out three valid timer digits, and we're going to simply construct a triangle as shown on the diagram on this right here, by filling it from digits 0 to 9. And we're going to start with the first digit in this serial number at the top, and then continue in reading order, going from the next digit. And if we happen to get to 9, we'll wrap back around to 0 for the next digit. So let's take a look. So our first digit in this case is a 5. So 5 will be at the top of this triangle here. And we will simply mimic the way that this triangle looks by inputting the digits where the ends are in this case. So we're going to do 5, then we're going to go down to the bottom left in this case in reading order. And the next number for that will be a 6, as we're going to simply be doing it in numerical order. Then the next one off into the bottom right following the arrow is going to be 7. Then the next one, in this case we're going to go down to the third row in this case. So in this case we're going to be doing 8 will be our next number, then 9, and then once we exceed 9 we're going to wrap back around to 0, 0, and then lastly for our last row in this case it's going to be 1, 2, 3, and 4. And so now that we have our triangle made, it mimics the exact way this triangle looks, and this is what we're going to be looking at here. Next up, what we're going to be doing is we need to actually find what our hazard is in this case, based off of this description here. And what these descriptions give you is we have the name of it, and in these brackets here, it will give you what is actually depicted on the module. So in this case, a general wording would just be an exclamation mark. Flammable material would just simply be flames. But in this case, what we have here is a person falling. So in this case, this corresponds to risk of falling. So now that we found our hazard, what we need to do is figure out which column we're looking at to obtain a specific number. So this is indeed a solve-dependent module case. So this is referring to the number of unsolved modules, which also, mind you, includes needy modules. So since this is the only module on the BOM, let's take a look. So then if the number of unsolved modules is a multiple of 4, in this case 1 is not a multiple of 4, and it goes on to say multiple of 3 and multiple of 2, in this case none of those are true. So in this case we're going to be using column G. Please note that we will be using column G for all of these, just to simplify the rules, but make sure you're always paying attention to the number of unsolved modules, not the number of solved. So in this case, let's use column G. So column G will give us a number, in this case being 6. Now, this is actually not relevant to one of the three timer digits that we need to find. What we need to do is, in the triangle, we're going to find all possible equilateral triangles in which the received number appears in a corner position. And then what we're going to do is locate the three numbers that don't appear in corner positions of these triangles. So this is where things actually get a little bit tricky to understand. Now, normally we think of equilateral triangles as these small guys. So for example, at the top here, it would be the start, this bottom left November, and this bottom right November. However, this module will can also be a bit bigger, for example. So let's take a look at what I mean by that. So we obviously have this 6 right here. So that in this case would be a corner position. And the equilateral triangle that it would correspond to in this case could also be 5 and 7. And those three make an equilateral triangle. However, let's branch out a little bit. We actually can do 6 in a corner position with 1 and 3. And this is what I mean by these can be formed with equilateral triangles in a bunch of weird and wacky ways. So what we need to do is we need to find the 3 that actually don't form an equilateral triangle with it. So let's actually find the ones that do form an equilateral triangle with it. So in this case, we said 5 and 7 right here. So 5 and 7 are automatically off the hook. And then 6 in this case also can do 8 and 9 as an equilateral position. So 8 and 9 are off the hook. And then as we said beforehand, 6 can also be corresponding to 1 and 3. 1 and 3. And now, taking a look at the diagram here, 6 does not correspond to 0, nor does it correspond to 2, nor does it correspond to 4. We cannot form equilateral triangles with any of these 3 numbers. So in this case, we have found our 3 digits that we must screw at specific times. So we're going to unscrew these screws present on the module based off of these 3 times. But the catch here is we cannot do them in any random order. While the positions of which you screw them is irrelevant, what we must do is we need to make sure that unscrew one screw for every valid digit timer. Moreover, the whole process cannot exceed 9 timer ticks from the first screw. Taking too long or unscrewing on an invalid timer digit will result in a strike. So in this case, what we actually need to do is we actually simply need to reorder this string of this 3 digits based off of the greatest to least, and that's what we have to screw in. So we have to unscrew these guys at 4, 2, and 0. And just like that is a solved module. So the positions of which you unscrew these modules at is irrelevant as long as you unscrew them at good times. That's what we're worried about here. So it is also important to note that it has to be quick. It has to be very quick. Once you unscrew the first one, you have to unscrew the rest within the span of 9 seconds. So just be careful about that rule because that's probably what's going to mess you up the most. However, the order of which, as I said before, you unscrew them is completely irrelevant and it's not based off of the positions that you receive on this triangle here. So let's take a look at another one here. So this guy appears to be slipping almost. And let's take a look and see if we can figure out if there is something similar to that. So, first thing slipping, slippery 4. So now, let's reconstruct the triangle based off of the first digit again, in this case. And in this case, it is a 1. So we have 1 at the top, and we're going to have 2 and 3, then 4, 5, and 6, then 7, 8, 9, and lastly 0. So the number that we're going to be looking at to find equilateral triangles for is 9. So 9 in this case can correspond to 9, 6, and 0 as one equilateral triangle here. 9 can also correspond to 9, 5, and 6 as well. The direction of which the equilateral triangles appears is not relevant. As long as they form an equilateral triangle and as long as they can actually be reached. That's what matters here. And lastly, 9 can also be formed with 9, 2, and 7 in this case. Let me make sure. Oh, and lastly, 9, 5, and 8. The numbers I did not mention were 1, 3, and 4. So those will be the 3 missing digits that we need to simply unscrew these screws on here. So 4, 3, and 1. So let's do that. So we'll do 4, 3, and 1. And just like that is a solved module. Let's look at one final example. This appears to be just a simple thermometer. So let's take a look. So thermometer, high temperature, and this will be corresponding to the number of 0. So let's reconstruct the triangle again. And our first number is going to be 3. So 3, then 4, 5, then 6, 7, 8, then 9, 0, 1, 2. So our number, as we said, was 0. And the one that I'm always forgetting, and the one that I always kind of overlook, is the fact that the entire corner can actually be an equilateral triangle. This, in this case, does not apply, but 9, 3, and 2 in this case would be able to correspond to an equilateral triangle. But we're looking at 0 in this case, so let's figure out which 3 are missing. So we can form an equilateral triangle with 0, 6, and 9, as well as 0, 7, and 1. We can also form one with 0, 5, and 2. And just like that, we have our last three remaining numbers. In this case, we cannot form one with 8, 4, or 3. And these will be the three numbers we have to unscrew the screws with. So now, let's take a look at what happens if I happen to accidentally unscrew at the wrong time. For example,
I'm afraid I
nothing
can't
changes.
take it.
So now let's say what happens if I happen to go over the 9-second limit.
It's hugely frustrating,
Right,
isn't it?
also given. So you have to be careful with that. That's exactly what I mean, is that you have to be a little bit quick with it, and it can be a bit tricky. So let's try this again. So 8, 4, and 3. And just like that, this is a solved module. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I'll see you guys in the next one. Bye-bye.